Hi, welcome back. In this lecture, I'm going to talk about tuples. That is a different way to implement and use arrays in Python. By the end of this lecture, we'll be able to describe the tuple features, why they're important, how they can be used. We will be able to list the advantages and disadvantages of tuples when compared to Python list. And finally, we will be able to describe what is resource caching and how it is used in tuples for performance. So tuples are fixed and immutable arrays. So this is very different from what we saw in listed, where dynamic and we had the possibility of resizing. So what it means that tuples are fixed and immutable? This means that once a tuple is created, unlike a list, it cannot be modified or resized. So let's take here an example. We create a list. So here, we created tuples. Instead of having the square bracket, we have the normal parentheses. And you see here we create our tuple with 1, 2, and 3, 4. Then we try to modify this element of the tuple. We want to make it fixed. If we try to do that, then Python will throw an error. As you see here, tuple object does not support item assignment. Right? So we just initialize, but then this operation is not allowed. It's true that resizing is not available, so we cannot do the operation of appending, but what we can do is actually to we can concatenate two tuples together and form a new tuple. This operation is similar to the resize operation, right? And we are going to use this plus operation. So in this slide, we have this example. We have T1 and T2 that are two tuples. We do this plus operation that is concatenating the two tuples, and we obtain these tuples. That is the combination of the first tuples plus the second tuples. So comparable to the append operation on the list, that is an operation that is constant time. Concatenating is quite expensive operation and performs with a complexity that is big O of n, where n is the size of the tuples. This means that increasing the size of the tuple, this concatenating operation will increase linearly with the number of elements in the tuples. The reason for that is because when we do this concatenating operation, we must allocate and copy the tuples every time something is added, as opposed to only when our extra headroom ran out for the list. Like in the case we saw for the list, we know that we are over allocating. So that means that we do this resizing suddenly to avoid the extra allocation. So for the tuples, there is no in-place append-like operation like we saw in the list. So because the tuples, they don't use this extra headroom like we saw for the list, the tuples has the advantage with respect to the list of using fewer resources. So we're not over-allocating more memory for tuples. A list for 100 millions, we create with any append operation a much larger list because of the overallocation. And in the case of tuples, we can avoid this overallocation. So this will be exactly 100 million elements, right? So we can see here, the benefits of using a tuple in the usage of resources. So there is no headroom, there is no extra usage of overallocated memory. Tuples, when it's possible to use, so whenever we have some values that we don't need to modify, is much more preferable than the list, because the tuples are lightweight and it is static. So it's much more high performance data layout for our arrays with respect to list. So when the data is static, this is much better approach. Another benefits of using tuples and exploiting their static nature is something that Python is doing in the background called resource caching. Python, in fact, is a garbage collected language, which means that if the variable isn't used anymore, so the reference is not available anymore, Python actually frees automatically the memory used by that variable, giving back to the operating system for using the other application or for other variables. That means that we are using the same variable, and after being deallocated, we need to repeat the allocation, spending quite a lot of time. Remember that any allocation requires time, because allocation requires to talk to the operating system, to the making a system call, and that takes some time that is impacting the performance. For tuples of size 120, when they are no longer in use, the space is not immediately given back to the system. So up to 20,000 each size are saved for future usage, right? So they are cached. This will mean that when a new tuple of that size is needed in the future, we don't need to communicate with the OS to find a region in memory to put that data into. However, in this case, we also know that the tuples, the resource, they use some cache, so they will also use extra memory overhead, but this memory overhead will result in avoiding extra allocation, so give us performance. Tuple can be created easily and quickly, since they can avoid the communication with the OS, any system call. And what we can do is we can compare the time to create a list against the time to create a tuple. As you can see here, we use the magic command, the time it, to tell how much time is spent to create a list, and we'll see that is 37.9 nanosecond on my machine. If we do the same operation on a tuple, then this execution time is much lower, roughly 6 times less. In this case, instantiating a list can be 6 times lower than instantiating a tuple. To summarize, this is the last slides of this lecture. Tuples are fixed and immutable arrays, so if we try to modify an element of tuples, we will get an error. The concatenating operation is quite expensive. It's similar to append list, but it's quite expensive, and it scales with the number of elements that we need to add. Tuples use less memory than list, and tuples are also cached, so we don't need to communicate with the OS if tuples are used. This is the last slides of this lecture, and talk to you soon.